also a disappointment, but here we are. I'm a disappointment.
All right, so geometry. On Thursday, the 20th of August, SMBA students will be able to measure line segments. Section 1.2, we're going to learn how to measure line segments, okay? So let's flip over to 1.2 if you haven't already. So we have these things called postulates. Postulate, another name for it, is called an axiom.
You need to play the game.
Yep, I'll play it in a bit. It's called an axiom. Now, an axiom or a postulate is a rule that is accepted without proof. So it's just something we accept to be true without having to prove it, because we have to build other things on top of it. In society and life and in science in general, actually, there are certain things you just have to accept to be true that you can't prove. Okay, you can't prove that to be true, but you have to accept that to be okay. Well, this is a fact. So that way we can build on other things. Okay. So a theorem, though, is a rule that can be proven. So because we have these postulates, which we just say this is true, we can then use those postulates and say, okay, well, if these things are true, then this would also be true. And that would be our theorem, okay? A theorem. That comes similar to the word theory. A theory is something you say, okay, well, is this true? And then you go and test it, and you figure out one way or the other. So a theorem is something that was tested and figured out, oh, this is true, it was proven. Now you guys might remember from algebra, the absolute value. Absolute value is the distance a given point is from 0 on a number line. It is the distance from 0. And its absolute value is always what? Writer?
Positive.
It's always positive. It's always positive, okay? And here's the reason why. You can't have negative distance. You can't have a negative distance, okay? Have you ever said, let's go drive negative 20 miles? No. Or let's go run negative a mile today? No, it's always you run positive or you move positive distance. You can't move negative, okay? Even if I were to say, I'm going to move forward 2 squares. If I move backwards, am I moving negative 2 squares? No, I'm still moving 2 squares. I just say I'm moving 2 squares backwards, okay? Or if I were to drive from here to Bellevue, okay, I'm going to drive about 15 miles or 10 miles, okay? And if I drive back, it's not negative. It's just I'm driving the other direction. I'm driving south. I'm driving back. Okay, Schroeder.
What if you move 3 squares back and you only move 2 squares forward?
Then I moved a total of 5 squares, 2 squares forward, 3 squares back. But I still didn't move any negative amounts. Okay?
Sorry,
Because you can't have negative distance. That's why absolute value is always positive. It's just how far away from 0 it is. So if we're measuring segment length, which we'll also be calling distance, if we're measuring segment length, which we'll also be calling distance, the length of the segment would be x2 minus x1, the absolute value of that. Now x2 and x1 are just names for 2 different points. It's 2 different points. Whenever you see the small number in the lower right hand, like this, small number in the lower right hand, it's just saying this is our second x, this is our first x. Now if it were up above, it would be an exponent, but it's not up above. So here on this line, we have like x1 and x2. These are like the x coordinates for it. Those are the coordinates, okay? So those are the coordinates. The coordinates. Where A and B are the names. So for these points, it's point A and it's at x1. This is point B and it's at x2. And the coordinate tells us where. The letter A and B tells us the name. Questions on that? Alright, we'll move on right below this. So if we're finding the distance between the 2 points, let's say we're finding the distance between T and W. Well, according to what we just said, we would call T and W, one of them x1 and x2, and we would take the absolute value of x2 minus x1. We take the absolute value of one point minus the other. So which one do we want to call x2 here? Which one do we want to call x1? Does anyone care? Kenny?
Just do it how it is.
Okay, so how is it?
TW X1.
Alright, so T would be x1 or x2, then W would be the other one. So which one would be which? T x1 or x2?
X2.
X2? So Kenny wants to call T x2 and W x1, okay? So if T is x2, that means x2 is negative 4. Because it's at negative 4 on our number line. Left to right is our x. So we're going to have the absolute value of negative 4. And I like to substitute in parentheses, just in case we have a lot of negatives here, minus whatever x1 is. So what's the value of W?
10.
10. So minus 10. So we have the absolute value of negative 4 minus 10. Please don't draw me, that's funny. Right? So what's negative 4 minus 10?
6.
Wait, so are these? So when it's a negative getting smaller, Tyler?
Negative 14.
Negative 14. Negative getting smaller. So another way to think of this is you can always change subtraction to addition. But what do we have to do if we change it to addition? Anyone know what we have to do if we change it to addition?
Change it. Teacher, change it, flip it.
Change the opposite sign. Change the sign after it to be on the opposite. So this becomes a negative. So two negatives become a bigger negative. If it's the same sign, negative and a negative are the same signs, you add the numbers, 14, but you keep the sign negative. So whenever you add two numbers of the same sign, you add the numbers, and the sign stays whatever it was. So what is the absolute value of negative 14? How far away is negative 14 from 0? Schroeder?
14.
Just 14, because it'd be positive. So that means the distance between T and W is 14. How else could we find this, guys?
Do it.
What do you mean do it?
Do the graph.
Kevin? You can count them, right? You can go start at T. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did we get the same thing actually just going through and counting? Yes. Now before I asked, hey, which one do we want to call x2 and x1? What would happen if we switched them around? What would happen if we said, okay, well actually, I'm going to call Tx1, I'm going to call Wx2. So instead of doing negative 4 minus 10, I'm going to do 10 minus a negative 4. Well, what happens when I'm subtracting a negative? Okay, we might know what a keep change. We add the opposite of what's there. Okay, so what's 10 plus 4?
14.
14, so we have the absolute value of 14. What's the absolute value of 14? Did we get the same answer?
Yeah.
So did it matter which point we started at?
No.
No, because just like if we went through and counted, we went through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, we get the same thing. Doesn't matter which one you start with, so don't be concerned about saying which one minus which. Just do whatever is easier. If it's easier for you to do 10 minus a negative 4, do that. If it's easier for you to do negative 4 minus 10, do that. Whatever is easier for you. So on letter B, this between B and W, I want you guys to try and find that one on your own. So I want you guys to do letter B, this between B and W on your own. Once you have it or have questions, raise your hand. Once you have it or have questions, raise your hand, okay? And this has one I will come around and check you. Okay, very good. Very good. Very good. All right, let's go and talk about this one up here. So some of us might have just counted right away and just been like, and we know it, okay? Others of us, we might have gone through the absolute value portion of it and said, okay, well, I'm going to do one of them minus another. So maybe you did 10 minus 8, the absolute value of 10 minus 8. And said, okay, well, that's 2. Absolute value of 2 is 2. Also count 1, 2, or the other way, 1, 2. And we also could have done the absolute value of 8 minus 10. But regardless, the answer is 2. Questions on that one?
I got my quick pencil.
Okay. Good. Good. So we have these things called congruent segments. Congruent segments. So these are segments that are equal in length. These are segments that are equal in length. So in geometry, we have this thing called congruent, and it just means they have the same length, okay? So distances are equal, but the actual parts, like segments, are congruent, okay? Now the symbol for it, it's pretty similar to equal, but we add a tilde to it, okay? Just like from Spanish, okay? Now we don't just say it funny like equal, okay, like you add an accent to it like you would in Spanish, you know, like jalapeno, but it's actually jalapeno because of the tilde, okay? It's not equal, it's just, it's congruent. Some people also say this looks kind of like a toothbrush with toothpaste on the top.
It does.
Yeah, we get that every year. Okay. Presley's not seeing it. Yeah. I saw as soon as I said that, Presley's like, okay. So from our number line on the previous section, number line in the previous part, what are two congruent segments? What are two segments that are equal in length? Maybe between two of those points. So segment blank blank and segment blank blank have the same length in that number line right above there. Let's go back to this number line. So what are two segments that have the same length here? Okay, Ryder.
S and T and T and U.
Yeah, segment ST has a length of 3, and segment TU has a length of 3. So to answer the question, we could say segment ST is congruent to segment TU. It is like you say two things are equal, we'll say two things are congruent, but with segments. Segment ST is congruent to segment TU. You could flip it around as well. You could put segment TU first and segment ST last. We could also call segment TS instead of ST, okay? All sorts of things, okay?
Street.
Questions on number 2 and why we put that? Okay? On number 3, now we do this thing where we label, where we label our segments. So whenever you see a tick mark on a segment, it means it's congruent to another one. Now this one with one tick mark is going to be congruent to this other one. Will this one with one tick mark be congruent to another one with 2 tick marks?
No.
No, it looks like the number of tick marks kind of match up, doesn't it? Okay? So, can somebody tell me a pair of congruent segments in this? Okay, Schroeder.
G and C.
G and C is not a segment. So segment blank blank is congruent to segment blank blank.
Segment CD is congruent. Segment GF.
Very good. Segment CD is congruent to segment GF. That'd be the one with the 1 tick marks, okay? Somebody want to give me another one? We have 2 more sets here. Okay, Elizabeth.
Segment F.
Okay. Segment FE is congruent to segment DE. Very good. And if you want to call that ED versus DE, that's fine. Or EF versus FE, that's fine. And then we have one more pair of segments here that are congruent. Okay, Ray.
AG and BC.
Yeah, segment AG and segment BC are congruent. Very good, very good. Okay. So we're going to have this thing for our labeling, okay, where distance versus segments are going to be labeled slightly different. So maybe the measure of segment AG is equal to the measure of segment BC. So we know the measures of these segments are going to be equal because they're congruent. Now right now, do we know what the measures are?
No.
No, okay? But those would both be equal to some number. Those would both be equal to some number, right? Whether it's 5, like 5 units long or whatever. is going to be equal to some number. Whereas in the for the actual segment itself, you would say that segment AG, the segment is congruent to another segment. So what I'm just trying to drive home here in this part is that the distances, the measures, can be equal because they're a number. But the actual segment itself are congruent, not equal. So segments are congruent because it's a part. Okay. But distances are a number, measures are a number, so numbers can be equal, okay? Questions on that? All right, let's continue on.
What about labeling?
That's part of this hint. Yep. It's a labeling thing, okay? So we're going to plot these points, plot J, plot K, plot L, plot M in the coordinate plane. Then we're going to determine whether those two segments are congruent or not, whether segments JK and segments LM are congruent or not. Okay? So can somebody help me plot point J? Where do I go from the origin? Where do I go from the origin here, okay? Schroeder.
You go 3 to the left,
Okay?
and then up 4.
And then up 4. Okay? So we do x comma y, remember it's x comma y. So left and right first, and then up and down to the next, okay? Somebody else want to help me with point K. Somebody else want to help me with point K. Okay? Elizabeth.
You go over to 2
Okay?
and then up 1.
Very good. So 2 is positive, so we go to the right now, like on a number line. Okay, Tony, you want to help me with point L? Yep. Awesome. Perfect. It's way my favorite 20 minute here, you know. Okay, see what I did there? Okay. Somebody else want to help me with point M? Okay, Ian, you want to help me with point M? Okay. Perfect. So now we're going to connect these because we're told whether segment JK and segment LM are congruent. So I'm going to make a segment between J and K. It's asking about segment JK, so I'm going to make a segment between them. And it's also asking about segment LM, so I'm going to make a segment between them. Now, can somebody tell me whether or not those two segments are congruent or not? Are these segments congruent or not? Chase, what are you thinking?
Yeah, because they're both 5.
They're both 5, okay? So the measure of JK, segment JK, that's 5. M stands for measure, the little m stands for measure. Measure of segment LM is 5. So the measures are equal, right? The measures are equal. Well, if they're equal in length, equal in measure, equal in distance, any of those words mean the same thing, then they are congruent. So we can say segment JK is in fact congruent to segment LM. So because the measures are equal, they're congruent. So a lot of times before in math, you had to show your work, right? You had to show your work for your explanation to get partial points, that kind of stuff. Right here, this measure part, that is your work. In geometry, this is your work right here. And then this is your answer. So if you're wanting to get partial credit, so maybe you got this part wrong, but you had this part right, that's how you get partial credit for this. Okay, questions on that? Any questions on how we do the measure with 5? We remember this count, right? Okay. Or you can also do the absolute value like we did. Do, okay, what's the absolute value of 2 minus -3? Oh, it's 5. Alright, so we have this thing where we can add 2 segments together. We can add 2 segments together to get a whole thing, okay? So for segment addition, I'm going to say that if I add, oh, actually, here's what I'm going to do. I'm going to get creative with this. Okay? So if I have segment AB, I'm going to say this is part of the whole thing. Okay, A to B is part of this whole big segment, right? AB is like a little bit of part of the whole segment AC. And I have B to C, that's another part. Well, what do, I just changed from that one. Oh, that's one I was going to use. Right? What do red and blue make? Purple. So you have those two parts, segment AB and segment BC, can come together to make the whole big segment AC there, right? You see that in the colors, hopefully? Okay? So something I like to say is segment addition means that you have part plus another part equal the whole thing. We're saying we can take two parts of something and it equals the whole thing, okay? So to put it down here, okay, if I go from the door to my stool, okay, we're talking 3 squares. 1, 2, 3. Okay, now if I go from my stool to, let's say, the stool to the water / Avengers poster, we're going 1, 2, 3, 4, 5, 6, 7, 8 squares, okay? So it's 8 squares from the stool to the water, 3 squares from the door to my stool. How far is it from my door to my poster? 11. 11 from the door to the poster of water. How did you get that, Schroeder?
Because I have them.
You add them. 2 parts can make a whole together there, okay? So, can we find the length of segment AC then? Right here, if we know the length of segment AB to be 13, length of segment BC to be 27, raise your hand if you can tell me what the measure of segment AC would be, what the length of segment AC would be here. Ray, what are you thinking?
40.
It would be 40. You added those two together. It would be 40 because 13 plus 27 is equal to 40. Now we told a unit here like 40 inches or something like that. No, so we just call it 40. Okay. Questions on that? No. You guys are doing great. All right, find the length of segment GH. So, here, is this quite the exact same thing?
No,
No, but it's pretty similar. What's different about this one?
the F and the G are too big. We use subtraction.
We're going to have to use subtraction. Ray, how would you set this one up to find the length of segment GH?
36 minus 21.
Yeah, because in here, instead of us having part plus part equals a whole, part plus part equals the whole, we already know the whole and we know a part. So if we were to fill these in with with math, we'd have 21 as a part, another part is x because we don't know this, and the whole is 36. So we can turn this into an algebraic equation and say let's subtract 21 from each side, get x by itself. So x is equal to 36 minus 21, which is
13.
15. So that means the measure of segment GH, to answer our question, the length of GH, the measurement of that, which is the length, is 15.
How is that bigger than the 21?
I know, right? So here's the thing. ACT and other standardized tests will do this stuff all the time. Math test, okay, will do this stuff all the time, okay? Where this GH looks way bigger than FG, right? But somehow this is 6 less. Because this is 15 and this is 21. How does that work? Well, they'll say a little thing. Pictures are not necessarily to scale. Pictures are not to scale. Meaning, hey, the picture's not entirely accurate, so you can't say, because this is bigger, it has to be a bigger number. They do that stuff to throw you off and make sure you actually are just paying attention to the math, okay? So heads up, those tests get tricky. Great question, Ray. I love that you pointed it out, you caught that. Does anyone have questions on how we did this problem, though? Okay, we went through subtraction, okay? So if you see right away, oh, I just know I need to subtract them, awesome. But if you want to say, okay, well, I know 21 plus this unknown, so I'll call it x, equals the whole thing, and go through an algebra equation to solve it, do that. Okay, now this is our last example for the day. This is our last example for the day. Okay? Example 7. Find the value of x and jk if k is between j and l. So find the value of x and the length of jk if k is between j and l. Now we're told the length of jk is this, kl is this, and jl is this. Whew, okay? This is similar to a word problem, kind of like an algebra, but in geometry, we need to draw a picture. So just like in algebra, a lot of our big hit with word problems is to draw a picture. Here, we've had pictures for the other things. We need a picture here. What do we think we might be drawing? A line segments, okay? So if I draw a line segment we know has 2 points. Okay? How many points should I actually put on this though?
3.
3. What should I label these points?
J, K, and L.
J, K, and L. Does it matter which point's where?
Yes.
Okay, yes. Kenny, what matters?
K is between J and L.
K is between J and L. Do we really care which side J and L are on?
Yeah.
No. Well, let's maybe go alphabetical. Do J on the left, K on the right. But we know K has to be between them. Next, I'm going to fill in the other information I know. I know the measure of JK is 3x minus 4. So I'm going to say, okay, from J to K is 3x minus 4. Let me try and redo that there. From J to K is going to be 3x minus 4. And so notice how I do these little bars and this line here to show that's only from there. And I know KL, segment of KL, has a measure of 5x plus 8. So I'm going to put that just above the KL. That way it's a little more descriptive and saying, okay, well, that's just above this part. And I know the whole thing, J to L, is what?
140.
140. So I know the whole thing is 140. Well, can we set up an equation from this?
Yes.
Okay, can somebody raise your hand if you want to help me set up the equation for this one? Raise your hand if you want to help me set up the equation for this one, okay? Kenny, what do you think, buddy?
3x minus 4 in parentheses.
Okay.
And then 5x plus 8 in parentheses
Okay.
equals 140.
Oh, so Dayton said he has them multiplying. That's the only thing I disagree with.
Subtract.
Okay, not subtracting. But are these are 2 parts, or is one of them a whole?
2 parts.
2 parts. So what do we do with the 2 parts to get the whole?
Add.
Add them. So this is the same thing as part plus part equals the whole. We have 3x minus 4, part of it, plus the other part of it, 5x plus 8, equals the whole thing, 140. Any questions on how we set this up? Okay, we're going to be going back and using this kind of thing a lot in this class, so if you have a question on how to set up, now is an excellent time to ask. Okay, from here we continue on solving this problem. We continue on solving this problem using our algebra skills. So a lot of times what happens in geometry is we use our geometry to set up a problem, and then we use our algebra skills to solve the problem. Okay, we use our geometry to set it up, and we use our algebra to solve it. So, how would I go about solving this problem? What would be my first step? Kenny?
Dealing with inside both parentheses.
Okay, can we subtract 3x minus 4?
No.
Okay, so we want to try and do what's inside the parentheses because PEMDAS, okay? But we can't actually combine these anymore, okay? Well, can we go ahead and add like terms together though?
Yeah.
Since these are adding? Yeah, we can combine like terms. So Presley, what's a pair of like terms we see? 3x and 5x are the same variable x to the same power of 1. Shorter math one. Okay. So what is 3x plus 5x?
8x.
8x. Do we see another set of like terms we can combine? Okay, Schroeder, what are you seeing?
-4 and positive 8.
-4 and positive 8. So it's -4 plus 8 here, Kevin? 4, very good. Different signs, negative and a positive, so different signs, when you add them, you actually subtract. And you keep the sign of whichever number is bigger. So 8 minus 4 is 4, 8 is bigger, so it's positive. And that will now equal 140. So 8x plus 4 equals 140. What would we do now to solve this equation? We want to try and get x by itself, right? Because we're asked to find the value of x. Chase,
-4.
you subtract 4 on both sides, right? We need to isolate or get x by itself. So we have to do the opposite of what's there. So 4 minus 4 is 0. So it gets rid of it, because you don't have to put plus 0. What's 140 minus 4?
Well, 136.
136. If you need to do any of this work off to the side, that's perfectly okay. So now how do we get x by itself? Divide by 8. Very good. You have it multiplying with 8, so we say what's the opposite of multiplying? Dividing. 8 divided by 8 is 1. You have 1 times x, which is the same thing as just x. Does anybody know off the top of their head what it is that Gavin already found it, but you just know this one? Probably not many of us. Okay? So we can do this off to the side just fine. We're going to go over it real quick. Does 8 go into 1?
No.
No, does it go into 13?
Yes.
How many times?
Once.
Once. So 1 times 8, 8 times 1 is 8. What's 13 minus 8? 5. Does 8 go into 56?
Yes.
How many times? 7. 7 times 8 is 56. So this works out nicely with no remainder. So x is 17. Woo! Are we 100% done yet?
Nope.
No, we're close. We found x, but what else do we need to find, Kenny?
2 parts.
Actually, we just need to find one part. Just jk.
Oh, yeah.
So we actually just have to plug it in to jk. So we plug x back into jk, thing with jk, so we can find this one. So 3x minus 4. Instead we put 3 times 17 minus 4. So because x is multiplying to 3, 17 is going to multiply to 3. 3 times 17, if we don't know that one off the top of our head, we can go ahead and do that work as well somewhere. And I might do it up here just to give myself room. 17 times 3. What's 3 times 7? 21. Okay. What's 3 times 1? 3 plus 2? 5. So we have 51 minus 4, which is
47.
47. So we can say the measure of segment JK is equal to 47, and x is equal to 17. Those were the two things we were asked to find. Was that a bit of a longer problem? Yeah. Okay, that'll happen a little bit more in geometry versus algebra, so our problems might be a little bit longer, okay? Whew, any questions on that? Okay?
Yeah, why'd you make us do it?
Because I'm mean?
You're
You already
fired.
do that.
Don't worry, it only gets worse.
You're fired.
Stating that's a positive attitude, I like it. Yeah, can I give you one instruction first?
You're fired.
Fired?
Yes.
Oh. Did you get a new calculator?
Yeah,
Nice.
I know, right?
Alright. Hey, so on this one, if you flip over to the back once you get it, there's the black